Bismillahirrahmanirrahim. In this video, I will solve problem 4.16 from the book Design and Analysis of Experiments by Montgomery. In this question, 6 algorithms were applied to several different software development projects. So 6 different algorithms, these are our treatments, applied to 6 different projects. These are our blocks, 6 different blocks. And the percent error in estimating the development cost. These are the costs associated with them. They are our response variable. So first of all, we have to identify, do algorithms differ in their mean cost? So only for the algorithm, we have to perform a post hoc test after the main analysis or analyze the residual. So we will analyze the residual for both one-way ANOVA and for the RCBD general linear model. And which algorithm would you recommend? So it will be recommended based on this part A from the post hoc test. So first of all, we will have to input the data in the Minitab software. Always suggest you people to enter the data with respect to the treatment whose name are given in the first column. So first of all, write slim for 6 times, because for the slim the data is available for the 6 projects. So first of all, I will do like this. Then I will write Kokomo A for the 6 times, Kokomo R 6 times, and Kokomo C for the 6 times. You can see it here. I have done with the Slim and Kokomo A. Now I am doing the data entry for the Kokomo R. I am going to drag it down till 18. Now I will drag the Kokomo to from 19 till 24. And the last one is, so data for the function points and HTML also done. Now we come towards the second column. Here the project. So projects are from 1 to 6. So we will have to write 1 to 6 just only for once, and then we will do copy and paste for the rest of them. So just write first of them, Control C, copy, Control V, again Control V, Control V, and here Control V, come down, and the last time press the Control V. Now go up and enter the data for the percent error. So you will have to enter the data with respect to first row, just 1244. So right here 1244, then 21, then it is 82 and 2221, 82, 2221, then 905, 905, 839. Likewise, enter the data for whole analysis. So for this purpose, go to stat, then go to ANOVA, general linear model, fit general linear model. In some of the software, it is written GLM instead of the general linear model. Select the response, percent error. My factors are algorithm and project. Click on graph, select 4-in-1, click OK, then click on results. In the result, select the expanded table, because it will give us the percentage contribution of each factor on the response variable. Then click OK. Now wait for the results. First of all, now we will do the residual analysis having the both factors in the results. So come down straight away and have a look at the graphs. So the residual analysis are perfect because the data is following the normal distribution as obvious from the normal probability plot and the plot of frequency versus residuals. Now we talk about this graph number 2, that is for the residual and the fitted value. So in this way, you can see that these points or dots are basically the residuals. So above this 0 dashed line, the residuals are positive, and below the dashed line, the residuals are negative. So we can say that the number of residual above this line are approximately equal to the number of points below this line. So it means that the variation in the data is constant, or assumption of the homogeneity of variance has been satisfied. Now the last one, a residual versus observation order. So you can see it here from the start till the end. There is no one pattern has been followed in the whole observations. So means that assumptions are satisfied. Now we come towards our result for the model summary and the ANOVA. The model summary depicts that 51.7% variation in the percent error has been explained by algorithm and project. So Now we'll talk about analysis of variance. I set the significance level at alpha is equal to 5%. So now the p-values for both algorithm and project, they are less than 0.05. So it means that there is a significant differences among the 6 algorithms for the percent error. Further, the project p-value is also less, so it is there is a significant blocking effect, or there is a significant difference among the 6 projects for the percent error. Now I will solve the problem part A. Do algorithm differ? So now in order to perform this, we will go to stat, then ANOVA. In the ANOVA one way, in the one way, we will now talk about here response is percent error. My factor is only algorithm. We will not take project. And then click on comparisons. Here select the Tukey, click OK, and then OK. Now we will see that first of all, again the residual analysis, and the residual analysis has been asked to check in the part number B. So we'll again come down and we will have a look on the residual plots. So now in the residual analysis, there is some issues with the data. The issues is basically mainly with the variance. Now the assumption of the variance is not satisfied. Reason, there is a funnel type data. So now we will have to perform the data transformation. So in order to satisfy the assumption, we can see that from the normal probability plot, the plot number 1 and here the plot number 3, the data normality is not an issue. The issue is with this outlier. This outlier should be investigated and should either be removed, or the experiment should be performed again. Data should be collected again with immense care, because this outlier is affecting our residual versus fitted value as well, because it seemed to be some kind of funnel data, and for the funnel data we must have to perform the transformation. The transformation on this data is also a problem, because you can see here we have few negative values in our data. So I have performed the transformation and it seems that only one transformation is possible. Let me do it in front of you, only 1 or 2 transformation. So you can see that what are the problem that I am facing. So first of all, square root. The square root of the percent error is not possible, because again I have negative values, so some values are out of the bounds. Now if we apply another one, like if I say that select all functions, and in the all function there are a lot of these things. So if I come down and I say that I want to apply some kind of exponential data transformation. So here are the exponential data transformation. Again, I will have to select the percent error. So here I say percent error, and the 5th number I want to save this thing. So click OK. Again, some values, again the warning for the exponential as well, due to this negative symbol, negative sign. Again go to calculator, and this time instead of doing these calculations and again, so we say that percent error multiply by again percent error for all of the values, and save this data in the 6th number. Then click OK, and we got our square term. This time there is no issue with the negative sign. Now go to stat, ANOVA, one way ANOVA, and here select 6th number, that is our square data. Again for the residual, click on graph 4 in 1, and then click OK, and here OK. So now we see that what is the latest update on our residual. Come down and here have a look. So again the same problem exists, and this problem is again mainly due to this one outlier. You can see it here, it's a very huge value as compared to other. So we will have to replace this value from the data, or we should have to delete it. So now I am going to delete the row number 4 data. Click on it, delete the cell. Again go to stat, ANOVA, one way ANOVA, select the percent error and response, click OK. First of all, we go towards our residuals, come down and here have a look at our residual. Now the residuals are perfect. So there was one outlier that has created the whole issue. Now we have a green signal for our post-hoc results, depicts that there is a difference between estimals and COCOMO A because the p-value is less than 0.05. Similarly, between the function POI and COCOMO A, Then if we come down, there is a significant difference between the last two, slim and estimal, slim and function POI. These 4 pair differences has made this ANOVA significant. Then the last part, which algorithm would you recommend for use in the practice? So if we go towards the mean value, so you can see it here, the function point, it has the least mean. If I come down here using the graph, so again the function point has the least mean. However,